Reduced working memory capacity is one of the most telling early signs that the brain's central processing system, its mental workspace, is under strain. Working memory allows you to hold several pieces of information in mind at once and manipulate them, whether it's remembering a phone number long enough to dial it, following multi-step instructions, or keeping track of a conversation while formulating a response. When this system begins to weaken, daily life becomes subtly but steadily more difficult. You may find yourself rereading sentences to retain meaning, forgetting details halfway through a task, or losing track of what you intended to say in a discussion. These lapses are frustrating, but more importantly, they are the brain's way of warning that the delicate balance between attention, storage, and cognitive control is faltering. Reduced working memory isn't just a nuisance, it is an early marker of broader cognitive fatigue and declining neural efficiency. The danger lies in how easily people normalize it. Many assume it's just aging, stress, or distraction. But when working memory falters consistently, it points to deeper inefficiencies in the prefrontal cortex and parietal regions, the areas responsible for temporarily storing and manipulating information. These regions rely on robust neural connectivity, rapid neurotransmitter signaling, and strong energy metabolism. When any of these systems weaken due to chronic stress, inflammation, poor sleep, or nutrient deficiency, the ability to hold and use information simultaneously declines. The result is a mind that feels overloaded, even when facing simple tasks. The warning here is clear. When working memory capacity begins to narrow, the entire cognitive structure becomes more vulnerable to distraction, error, and slower learning. At the biological level, working memory depends on the brain's ability to maintain active neural representations for short periods, neurons firing together to keep information alive long enough to use it. These firing patterns require stable dopamine and norepinephrine signaling and adequate blood flow to the prefrontal cortex. If those chemical systems become disrupted, mental juggling becomes exhausting. Sleep deprivation, excessive multitasking, and even constant exposure to digital distractions can overload the neural circuits responsible for working memory, effectively short-circuiting their ability to sustain focus. Left unaddressed, this decline can contribute not only to forgetfulness, but also to diminished problem-solving and slower decision-making. The good news is that working memory is one of the most trainable aspects of cognition. Targeted cognitive training exercises, especially those designed to hold and update information, can strengthen the neural circuits that support it. Digital programs such as BrainHQ, CogniFit, and Dual NBAC tasks are specifically designed to challenge working memory capacity. These exercises require users to remember sequences, monitor changing stimuli, and respond in real time, the very functions that falter when working memory declines. Just 10 to 20 minutes of focus training per day can enhance prefrontal activation and improve information retention and manipulation. The principle is simple but powerful. Consistent short sessions work better than long, infrequent ones because they trigger neural plasticity without mental exhaustion. Real-world training complements digital exercises. Try recalling short lists without writing them down, summarizing what someone just said in your own words, or mentally calculating totals while shopping. Reading comprehension exercises, learning a new language, or memorizing short poetry also engage working memory intensely. Even conversation, when you actively listen, process, and respond thoughtfully, acts as a working memory workout. Each repetition of these mental challenges strengthens the brain's ability to keep multiple ideas active at once. It's not about cramming information, but about teaching the mind to hold, shift, and retrieve data smoothly. Nutrition provides the biochemical foundation for all cognitive performance, and working memory is especially sensitive to oxidative stress and inflammation. Polyphenol-rich foods, berries, cocoa, green tea, grapes, and dark chocolate have been shown to protect neurons from oxidative damage and improve communication between brain cells. These compounds increase blood flow to the brain and enhance synaptic plasticity, helping the prefrontal cortex and hippocampus operate more efficiently. For example, flavonoids in blueberries and green tea stimulate the production of BDNF, brain-derived neurotrophic factor, a growth protein that strengthens neural connections involved in memory and attention. Including a daily variety of these foods, a handful of berries in the morning, a cup of green tea in the afternoon, or a small portion of dark chocolate, can create measurable improvements in mental energy and recall over time. Equally important is stabilizing blood sugar and maintaining hydration. The brain depends on a steady flow of glucose and water to function optimally, and even mild dehydration or glucose spikes can impair working memory. Avoiding highly processed foods and refined sugars helps prevent rapid fluctuations that cause mental fatigue. Instead, prioritize complex carbohydrates like oats, quinoa, and legumes paired with lean proteins and healthy fats for sustained focus. Omega-3 fatty acids from fish, walnuts, and flax seeds also improve synaptic signaling and myelin integrity, crucial for rapid information processing. Sleep and recovery remain non-negotiable. During deep sleep, the brain consolidates and integrates new information, transferring short-term representations into long-term storage. Chronic sleep loss weakens the neural synchronization that supports working memory, leading to slower mental updates and more frequent lapses. A regular sleep routine, consistent bedtime, minimal light exposure at night, and a cool, quiet environment strengthens prefrontal cortex efficiency. Short naps of 20 to 30 minutes during the day can also restore attention and refresh working memory after prolonged cognitive effort. Stress management plays an equally crucial role. Cortisol, the primary stress hormone, interferes with prefrontal cortex function, reducing the brain's ability to maintain and manipulate information. When stress becomes chronic, it diverts mental energy toward emotional regulation instead of task focus. Practices such as mindfulness meditation, controlled breathing, or Tai Chi help restore balance to the nervous system and re-establish cognitive control. Even a few minutes of mindful breathing before a mentally demanding activity can enhance working memory performance. Mindfulness trains the mind to stay anchored to the present moment, essentially retraining attention, which is the gateway to memory. Physical exercise further amplifies these benefits by improving oxygenation, neurochemical balance, and energy metabolism in the brain. Aerobic activities such as brisk walking, swimming, or cycling boost dopamine and norepinephrine levels, directly enhancing working memory and attention. Resistance training also contributes to neuroplasticity by stimulating growth factors and improving overall cognitive endurance. Regular movement, even in short bouts throughout the day, prevents the stagnation that leads to mental sluggishness. To translate these insights into daily life, adopt a routine that supports both structure and stimulation. Begin each day with hydration, a light physical activity, and a polyphenol-rich breakfast, such as oatmeal with blueberries or a green tea smoothie. Engage in short mental exercises mid-morning when alertness peaks. During work or study, use structured intervals, 45 to 60 minutes of focused effort followed by a short break to allow the brain to recover. In the afternoon, refresh attention with light movement or meditation, and limit multitasking to preserve working memory bandwidth. In the evening, consume antioxidant-rich foods like spinach or berries, review the day's key information, and maintain a consistent sleep schedule. The positive message here is that reduced working memory capacity is not a permanent loss, but a functional signal that the brain's circuits need stimulation, rest, and nourishment. The prefrontal cortex and hippocampus remain adaptable throughout life, capable of regrowth, reconnection, and rejuvenation. With sustained cognitive training, proper nutrition, quality sleep, and emotional regulation, most people can restore and even enhance their working memory well into older adulthood. Yet, the warnings should be taken seriously. Ignoring these early signs can lead to cascading declines in attention, comprehension, and reasoning. The brain thrives on balanced effort, challenge paired with recovery. Treat every small act of mental focus as exercise for the mind, and over time, the clarity, control, and flexibility of working memory will return, stronger and more resilient than before.